class, everybody. So we're going to do section 6.7 today. I'm also available to answer any questions from the last unit because I know, or the last section, because I know that one was kind of challenging with the word problems. So if you need any help with that, let me know. But our lesson today is basically about rational functions. So we've been doing a lot with rational expressions, which are like fractions with polynomials in them. And we just finished up solving rational equations where you have like some fraction that's equal to something and how to solve that. So rational functions are where you have a rational expression as the definition of your function. So remember, functions, you input something and you get a result out. So rational functions are ones where the rule that you follow to figure out what you get out of your function is a fraction with polynomials in it. So there's a couple of different things you need to know about rational functions. So the first one is that the domain of rational functions is often restricted. So remember, the basics of domain and range is that the domain is a list of all of your possible inputs. So this is a review from our function lesson. But if you had a really simple function like this, which is basically just pairs of inputs and outputs, the list of all of the possible inputs would be the domain. So you could input a 6 or a 9 or a 1 or an 8 into that function. So that's the domain. And then the range is the list of all possible outputs. So you can get a 9 out or a 4 or a 1 or an 8. So that would be the range. So with rational functions, usually you can plug in an infinite number of possible inputs. Because X could be anything. You could plug in a 1 or a 2 or a 7 or a million or a pi or like any possible number. However, there is one number that you could not plug into this function. What is that number? Yeah. Perfect. And why can we not have X equal 5? Perfect. Yep. So the main restriction on a rational function domain is that you can't plug in a number that would create division by 0, because if you were to plug in a 5, you'd get 13 divided by 0, which is an undefined number. And so there would be no output for that. So the domain for this function would basically be all possible x's, so any x that you could think of, as long as, which it's usually written in set notation. So you have like these curly brackets and it says you can have all x's such that, or as long as x does not equal 5. So on your homework, you'll have some problems where they'll give you a rational function and they'll say, what is the domain? You basically just need to fill in what x cannot equal. So that's the first thing to know about rational functions. And let's go ahead and practice it on this one. So this one is a little bit harder than the last one because the denominator is not in factored form. But if we were to factor it, what would the bottom factor to, what would that be in factored form? Perfect. Yep, because that's a difference of squares. So we could use our difference of squares formula to factor that. And when we look at that denominator, what are the restrictions on what x cannot be? Yep, 5 and -5. Actually, I'll write that as -5 and 5 just to line it up. Because in this first factor, if x was -5, that would create division by 0. In the second factor, if x was +5, that would also create division by 0. So in this function, x can be anything as long as it's not -5 or 5. Any questions on that so far? Okay, so that leads us to our next thing, which is the graphs of rational functions. So these are two example graphs of two rational functions. And if we look at the first one, what can x not equal in that first one? Perfect. Yep, it cannot equal -4. And if you look at the spot on the graph where x does equal -4, which is right here on the x-axis, and it's also every point along this line, because those are all the points where x equals -4, you'll notice that the graph never goes to that line. It never touches that line where x is -4. Now it can get really, really close to it, because if you had some number like right here, that was like negative 4.000001. Well, you could still plug that in and you get negative 0.00001 on the bottom, which is a tiny decimal. And when you take a number and divide by a tiny decimal, you get a really big number, which is why this graph goes up like that. But it would still work. It wouldn't create division by 0. It'd be division by a teeny tiny decimal. And same thing on this side, if you did like 3.99999, well, sorry, negative 3.99999, that again wouldn't create division by 0, but it would create division by a really tiny decimal, which makes it go basically to infinity. So this is what's called an asymptote, and it's called a vertical asymptote because it's going vertically. And basically, whenever you're looking at the graphs of rational functions, you'll always have a vertical asymptote wherever you would have division by 0. And on your homework, all of the questions are like multiple choice. So they'll give you a rational function, then they'll say which one of these graphs is the graph of this function. And you should be able to figure it out just from the vertical asymptote. So you'll say, well, I know that if x was negative 4, I'd get division by 0. So I need to find the graph where there's an asymptote at x is negative 4. And you can see in this example that holds true as well, because in this one, what would x not be able to be? 1. So x could not equal 1. And if you look at where x does equal 1, you can see that there's an asymptote there. So on your homework, you should be able to do it just from that. There is also, like, if you were to graph this by hand, you know, like if you ever had to do that, I don't know why you would, because we have graphing calculators, but if you did, hold on, I have a sneeze coming. It won't come. Okay, well now it's gone. But if you did need to graph it, there's also horizontal asymptotes. Yay, victory. Okay, so the horizontal asymptotes, those ones are determined by the division of the largest exponent. So if we look at this one, the largest exponent for the top polynomial is x. The largest exponent for this one is x. And if you divide those two terms, x divided by x equals 1, and you have a horizontal asymptote at 1. So that's what the horizontal asymptote is determined by. In this case, you would do 4 over x because the largest exponent on the top is a 4. The largest exponent on the bottom is an x. And if x gets really, really big, like, you know, like if x was like a billion or something, 4 divided by a billion gets, and like the bigger the number gets, it'll get closer and closer to 0. And so if you have a situation like that where it doesn't divide to a number, then your horizontal asymptote will just be at 0. Yeah, so that's what you need to know about the graphs of rational functions. Do you guys have any questions on that? Okay. Then the last thing that you guys will be doing is you'll be evaluating rational expressions. So this is really easy because you basically just plug in what they say to plug in. So like in this case, they're asking you for g of -2, which means what do you get when you input a -2 into the function g? So basically you just plug it into the function and you'd say, well, g of -2 is going to equal -2 plus 8 over -2 minus 5. So that would be 6 over -7. So that would be your answer for the evaluation. Now, you will have some problems on your homework that are a little bit more complicated evaluations, where you'll be evaluating these two formulas. So essentially what this means is you'll be inputting x into the function, inputting a into the function, subtracting the results, and then dividing by x minus a. On this one, you'll be inputting x plus h into the function, inputting x into the function, subtracting the results, and dividing by h. Now, you might be like, why are we doing these functions? Those seem really random and kind of complicated. The reason why they're having you calculate these in this class is because these two formulas are one of the most fundamental parts of calculus. Because this is basically another way of thinking about the slope formula. Because you know how when we were calculating slope earlier, how we would calculate slope as y2 minus y1 over x2 minus x1, or like you'd have 2 points and you calculate it out like that. Essentially what this is doing is they're choosing 2 points, x and a. So you could think about that as x2 and x1. So like, let's say, I don't know, x was -4, a was -3 or something like that. Well, the y coordinate of -4, one way you could think about this, the x coordinate would be -4, but the y coordinate is the function value at -4. Because remember, the y-axis tells us the output when you input whatever number you're talking about into the function. And so essentially, this formula is the slope formula, but written in function form. Does that kind of make sense? So this formula is basically just the slope formula, which is why they're going to ask you to calculate that several times. And the idea of calculus, for those of you who have taken it or you might take it, basically the idea of it is you're trying to find the slope of the line at of your graph at a specific point. So the way that they do that in calculus is they make these points infinitely close together and they find the slope of those two things. And how close those things are together is called the letter H. And so they basically have your point that you're looking at, and then they look at another point that's just a teeny bit away from that, and then they calculate the slope. So this is also the slope formula, but they're using H to represent how far apart the x's are. And this is what's called the derivative in calculus. So if you ever take calculus, this is how they calculate the derivative, and that's why they're having you do it in this class to practice plugging in these numbers and calculating that. So I'm going to go through one of the hardest examples on your homework. Most of the questions on your homework are not going to have a long polynomial like this. It'll just be something like x or x plus 3 or something like that. But I'm going to go through one of the hardest ones and go through the example of how you would evaluate it so you can see how to simplify it. Okay, so on this one, I'm trying to find this fraction. So I just need to go and evaluate each piece of this. So this first part, f of x, tells me to input an x into the function f. So when I do that, I'm going to get 2x squared minus 3x plus 7. Then I'm going to subtract f of a, which means that I'm going to input an a into the function. So when I input an a into the function, I get 2x squared minus 3x plus 7. But I'm subtracting this whole thing. I'm subtracting f of a. So I'm going to have to distribute that negative to those parts. And then that whole thing will be over x minus a. Is everybody good with how I plugged in all my stuff? Yeah. So the x's, like this part, is from f of x. The f of a, oh, yes, I wrote that wrong. Thank you. I see what you're asking. It should be like this. Thank you for catching that. Yeah, sorry, that would be really confusing. Okay, so that's correct. Is everybody good with that? Okay, so now I'm going to go through and simplify this. So that's going to give me 2x squared minus 3x plus 7. That part's the same. But when I subtract all of this red stuff, I'm going to get negative 2a squared plus 3a minus 7. And this is all over x minus a. Okay, now I want to see if I can simplify this at all. So I know that 7 and negative 7 will cancel each other out when I add those together. And then I also noticed that these terms are very similar to each other. So I'm going to group the terms that are similar together. So that would give me 2x squared minus 2a squared minus 3x plus 3a. So I'm kind of just rearranging my terms so that the ones that are similar are next to each other. And the benefit of doing this is that this allows me to do factoring by grouping. Because with factoring by grouping, I notice that in this first group, if I split this into two parts, this is like they have a 2 in common. And once I factor out the 2, then I have a difference of squares, right? Because x squared minus a squared is a difference of squares. So that can simplify to be 2 times x plus a, x minus a. Is everybody good with that? Because I kind of did 2 steps in one. Okay, so that's my first group. And then in my second group, I have a -3 in common, and that gives me x minus a. And all of this is still over x minus a on the bottom. So this is part of the way through factoring by grouping, but to finish factoring by grouping, because I still have this stuff plus this stuff, I look at, well, what factors do these two parts have in common? Yeah, they both have an x minus a. So I can pull out that x minus a, and that gives me x minus a times my leftover stuff. Well, when I take this part and I divide out x minus a, I have 2 times x plus a. So I have 2 times x plus a. And then on this part, when I take out an x minus a, I'm left with a -3. And so that's the stuff that's left over. And now this is in factored form because I have 2 things that are multiplied together. This one's kind of complicated and I might be able to simplify it, but I basically have 2 things multiplied together, divided by x minus a. And notice I have an x minus a divided by an x minus a. And so those will cancel out. And my most simplified version of this expression is going to be 2 times x plus a minus 3. And if you wanted to, you could distribute the 2 and write this as 2 times x plus 2a minus 3. That's probably how I would write it, but your homework system will probably accept that as well. Any questions about that? And again, this is the most complicated version of this on your homework. Most of the questions on your homework, your original polynomial is going to be something like x plus 5 or something basic like that. And you only have like 1 or 2 questions that are like this. And by the way, on these ones, you should always be able to do some type of factoring by grouping in a way that x minus a will cancel out on the top and the bottom. So if you don't see it immediately, try rearranging some of your terms or things like that until you get it factored in a way where you can cancel out the x minus a's. All right, so that's the first formula. So remember, this is kind of like the slope formula written in function form. The other one that you'll need to do is this one. I think it's called the difference quotient or differential quotient or something like that. But this is what derivatives are defined by in calculus. So in this one, the way that we would calculate it is we would say, okay, well, the first part of my formula says to input x plus h into the function f. So that means that everywhere that I see an input of x in my function rule, I'm going to put in an x plus h. So that's going to look like 2 times x plus h squared minus 3 times x plus h plus 7. Is everybody good with that part? That's probably the hardest part of this one. Okay, then I'm going to subtract f of x. So f of x is just 2x squared minus 3x plus 7. And I'm subtracting, I'm subtracting all of that. And then I'm dividing that result by h. Okay, so now I need to go through and simplify. So this part's the hardest part to simplify because you need to do x plus h squared, which means you need to FOIL it out. And when you FOIL out x plus h squared, you get x squared plus 2xh plus h squared. And if you want to, you can write out that fact FOILing if you don't know how to do that in your head, but I FOILed a lot. So I know that this FOILs out to this. And then I also have to multiply that by 2. So when I multiply that by 2, that's going to give me 2x squared plus 4xh plus 2h squared. So I kind of did like 2 steps in one. I FOILed that out, and then I distributed the 2 to all of those parts. Okay, then I have minus 3 times xh. So -3 times x is -3x. -3 times h is -3h. And then I have a plus 7. Then for this red part, I'm subtracting the entire red part. So I'm going to do negative 2x squared. And then minus negative 3 gives me positive 3x. Minus 7 gives me just negative 7. And all of this stuff is all over h. So the expansion part is the hardest part. Once you get that done, tons of stuff will cancel out because
2x squared, or is it just x squared plus xh, or is it 2x squared plus 4xh? Like, sorry, that's.
so the x plus h squared is what I wrote in the blue stuff. And then you have to multiply that by 2. So I wrote over my coefficients by 2, just because I'm running out of room. If you want to, you can do it in a couple steps and like do x plus h squared and then multiply by 2 and write it all out separately. But this is 2x squared plus 4xh plus 2h squared. Okay, so then you go through and you say, okay, well, there's a whole bunch of terms that end up canceling each other out. Because this 2x squared and this negative 2x squared will cancel each other out and add up to 0. Negative 3x and 3x will cancel out to 0. And 7 and negative 7 will also cancel out to 0. And what you're left with, whoops, I should change to black. What you're left with is 4xh plus 2h squared minus 3h all over h. Well, all of those have an h in common. And so you could factor out the h, and that leaves you with 4x plus 2h minus 3 divided by h. The h's would cancel out, and your final most simplified answer would be 4x plus 2h minus 3. Is there anyone in here who's taken calculus before? Okay, well, if you ever do take calculus, if you were to take the derivative of this function, it would equal this as h goes to 0. So as h goes to 0, that basically goes away. And the derivative of that function is 4x minus 3. So that's the last example I wanted to go over. Do you guys have any questions on any of this? Okay, awesome. So you basically have kind of like 3 different topics in this lesson. You have the fact that the domain is all of the possible x's except for the one that will create division by 0. You have graphs of rational functions, and then you have evaluating rational functions. And in those evaluations, you're going to have some complicated ones like this. So if you have any questions, let me know. I can answer questions from this lesson, and I'm also happy to go over any questions you had from yesterday's lesson, because I know that one was kind of challenging. So if you want to open up your laptops and work on your homework, I'll answer any questions you have.